And then along this process, we do a couple of values together, students get into groups, and we commence to fill in the table. And once we fill in the table, we ask the question, okay, what is this data telling us? So the graphing calculator display just allows us to visually show them what I expect that they're doing on their personal calculator. And again, this is free, it displays really well. And this is just one of the features of this. So across the bottom of the screen, I don't know how well you can see this, it shows you, I don't know if it's showing up very well here, but I'm in the calculator mode. We also have a graphing mode, and we can enter equations to graph things. So I'm going to move to the equation mode, and we could graph in 2 dimensions. So I also use this to display to students some of our transcendental functions. Let's remember our exponential, our logarithm, I did the negative exponential. So I can enter equations in here as well. So I've already entered the equation of interest, but the equation editor takes you back to the calculator. It has functions, so you can pick your function of interest, the logs, all kind of different functions. So it has a lot of functionality. Once you enter your function, you save it, and I think you can graph up to 5 functions at one time. So I'm going to graph these 3 functions on the same plot in 2 dimensions, and it notes for you in the appropriate color what graphic you're seeing. What I like about this particular setup, I like to use this last semester. I started using this last semester with Calculus 2 students to note regions bounded by various graphs. So in this one, what I like is you can manipulate the graphic to blow it up in the region of interest. So if we were in a Calculus 2 class, we might ask about the area of a region bounded by certain curves. So we graph all of the curves, note the region of interest, and then think about what integral we need to do associated with this. In Calculus 1, I generally just use it to display our different functions, our sine, cosine, transcendental functions, just to remind the students of what the graphics look like. And again, you can manipulate them to blow up or see a larger frame of what's going on. Another item on this that is really helpful, and I kind of encourage the students, I believe this has an Android part as well. It has something called references. So you could go in there into the references, it lists your algebra, calculus, and I could say, okay, let's go to algebra and let's talk about the algebraic laws. So it tells you the laws of addition, multiplication. You click on your law and it tells you, oh, I remember what commutative is. She keeps talking about commutative property, associative property. Oh, there's a little dictionary for me. For their calculus, they also have a tutor in here. Again, this is free. Calculus. Oh, what's the definition of the limit? She keeps telling us about this thing, but what is it? Okay, this is a fuzzy definition, but we can go to the precise definition, and here it references us back to the textbook or another source. Integration, all types of stuff in here. Again, all this stuff free for the students, free for us, and quick references to remember what's going on in their various math classes. So these are the type of things, I mentioned these things for teaching and learning. I encourage the students who may have forgotten their prerequisite information. After I quiz them on it, they figure out, hey, she's really serious, the prerequisites are important. I encourage them to find some references to get them back, to get them to where they need to be. And the biggest one that I send them to is the algebra references. So this is the free graphing calculator. I have a couple more to show you. Let's get back into our PowerPoint. And I just mentioned all this, the scientific calculator, we work the limit as x approaches 1. It has graphing capability, and the notable features I just mentioned are the references. And you can also graph implicit functions with this. Oops, I flipped my screen. If we go back to our equations, I could click on mode on the right corner, and it'll give me different types of functions. I have polar coordinates, parametric equations, implicit functions, inequalities, so I could change the type of function that I'm dealing with. And again, it provides a lot of flexibility for use in, across the calculuses. But the fact that you can graph these functions as well is pretty nice. So if we go to, for example, implicit function, I've included one, x squared plus y squared equals 4. Then I go to the graph, and this is our circle. And of course I can scale it, I didn't mean to, but you can. And it'll graph those nicely as well. So that's fun, and it's free, so it's even more fun, funner. No, okay. So our next app, oh yes, and it also does, you can find roots and intersections with this. So it's high functioning for a free app. The next app I'm going to talk about is Quick Graph. And there's a free version and there's a not free version. The not free version is $1.99. And I actually purchased the $1.99 version because if we try to, so I'm displaying here in preview mode the free version. You see my graphic on there, right? Quick Graph over in the corner. It's under, let's see, let me point out what I'm displaying. This is Quick Graph, the free version. So in the preview mode, you can see it. But when I go to click on it and try to display, it says you need to buy it in order to display. So they have disabled the VGA projection in the free mode to get professors to spend $1.99 if they want to use it in class. So I figure if students have to buy textbooks, I can spend $1.99 and buy the display mode because it's actually a very high functioning tool. So high quality graphics, that's the first part of that. So let's go to the version that I actually paid for. All right, so here again, I play around with this. These are just quick equations, a quadratic, y equals 0, x equals 1, and I've been using this since last semester, and with this one I used in my Calculus 2 courses. Draw your graphs, and the question asked to the students is, what is the area bounded by these curves? So once you have graphed the information, we look at it, okay, what are our regions of interest? What is our region of interest based on the provided graphics? One thing that I don't so much like about this one versus the other free graph is that we notice that on this picture, we're just seeing the graph. We're not seeing the legend associated with those. So pluses and minuses, but this is just the 2D version of it. What I really like about this one is the 3D graphics that we can do. So we can do 2-dimensional and 3D rendering. The great part about the 3D rendering is the pictures are just phenomenal. So Calculus 3, when we're dealing with multidimensional functions, this is when this stuff is just wonderful. So again, you don't see what equation is graphed, but the students will have in front of them what equation I'm graphing, so I'm okay with that for now. Okay, so this is a graphic of, did I put those up here? No, I didn't. Okay. This is a graphic of a 3-dimensional function, x squared plus 3y squared times e raised to the negative x squared minus y squared. So it's a funky problem. Okay, and the students are asked to visualize what's going on with this. So I have a grid graph here. I could tap it and make it a solid. We could rotate it. Okay, so what's going on and why do we see what's going on? How does the behavior of the exponential function and the quadratic parts affect what's going on? You could blow it up. You can make it smaller. You could rotate about an axis, so I'm going to rotate about the z-axis. Oh, messed it up. And if you mess up like I'm doing now, you could reset it and decide what you want to do. Now I'm rotating about the x-axis. Again, I'm going to reset it. Okay, so what I really like about this particular setup, besides the fact that I could play with it all day, okay, so we could view multiple functions on here. So again, I'm going to tap it. I don't know if you can see this that well. Let me change the background for you all. I have a dark background. Let's change it to, let's see, did it change? No. You can change the background colors depending on how your projection is working. Another aspect of this is you could display multiple functions. So I have one function displayed. I'm going to change my function. Now I'm displaying sine x plus sine y. That's a solid view of that. I'm going to change the graphic again. Now I'm displaying, and this one isn't as clear, sine x times sine y divided by xy. So I've displayed three different functions separately, but we could also layer them. So now I'm going to open up the other ones. And we see a variation of colors layered on each other. And if I do the solid, we'd see something like that. So sometimes it's informative if you're comparing surfaces to put them on the same graphic. Other times, seeing them separately is the most beneficial. And we have a grid mode, solid mode, a dot mode. It's kind of a mesh, and that's not showing up very well in here. So we could turn them off and turn them on as necessary in the teaching. So this is the three-dimensional. So this graph, as I mentioned, this product has 2D as well as three-dimensional rendering. And it's very helpful, particularly in the Calculus 3, to help students think through what's going on with the function. So you give them this function and you ask the question, what's the domain and the range of this thing? And they're all just staring at me. Let's graph it, and let's think about this a little bit more. What's the domain and the range of this function? And in Calculus 3, the reading gets into the fact that we get a lot of information from graphing these things. So we have to learn about the tools, some of the tools available to graph. So the students can use the free version, because if they're just using it on their device, they don't need to project it. But if I'm showing it to the class and using it in class, I had to come out of pocket $1.99 in order to, sacrifices be made to teach. But it's great stuff, great stuff. $1.99, I'm all for that. And it has a lot more functionality than I'm using at this point. Okay, so one more, and I think I'm over my time, sorry about that. One more.
You're fine.
Okay. So quick graph plus. Oh yeah, so yeah, in order, this is what kind of caught me. Everything was beautiful, then I was using the free version, came into class, tried to project it, it didn't work, and I'm like, oh, okay. So tomorrow I'll pay for it and we'll get it all. Other things that you get by paying: implicit graphs, 2 and 3D inequalities, which are great, again, for the whole calculus series, particularly Calculus 3. These 3D graphs are really nice. And I also, in Calculus 2, you can use it a little bit for volume of revolution. So you show them the 2D graph, and then show them the 3D graph, and ask them to think about, which axis did I actually rotate the 2D picture around to get the 3D rendering. So that kind of stimulates their thinking and kind of pushes them to use all of their resources. A lot of them have graphing calculators and add and subtract on them. So I'm like, there's more you can do with this wonderful piece of technology. And all the apps that I have shown have an Android counterpart, so students who have Android phones aren't left out. some of the Android technology isn't as advanced as the iOS stuff, but for the most part, they could keep up with what's going on. All right, so the last app